All right, so we are going to practice setting up the inequalities that have those absolute value bars with them. And remember, greater means we set up an or problem. And remember, we flip the symbol and we flip the sign. And then less than means that we make an and problem, which we create like a sandwich, where the negative is on one end, the positive is on the other, and then you'll have your solving part in the middle, okay? So this problem, the absolute value of 2x plus 5 is greater than 3. So greater is or. So that's why it says 2x plus 5 is less than something, or 2x plus 5 is greater than something. Well, when you look carefully, remember, if it's greater than 3, then one version is the exact same, greater than 3. Okay? But then the other setup, remember, is the opposite. So we switch the symbol, so it becomes less than, and instead of positive 3, it's negative 3. Okay? So then we just have two separate inequalities, we solve them, and then we'll get the two versions on our number line when we solve it. So negative 3 and positive 3. All right, and it's just set up, the smaller one's on the left, the greater one's on the right, because when we do sandwiches, that's how it'll set up. All right, so then we subtract 5 from both sides. Over here, we get negative 8, so we're subtracting 5. But over here, when we subtract 5, we get negative 2. All right, then we divide by 2 on both sides. Divide by 2 by each side. Divide by 2. So we get a negative 1 here. And we get a negative 4 here, and then there's a typo right there, that 2 should be gone. So x is less than negative 2, or x is greater than negative 1, okay? So the solutions are all real numbers less than, and I think I accidentally said negative 2, I meant negative 4. Less than negative 4 or greater than negative 1. So again, in this case, since it's greater, one goes this way, one goes that way, so we just put them on the same number line. So there's no equal to, so it's an open circle. Less than is to the left. Okay, over here, there's no equal to, so it's an open circle at negative 1. Greater than is to the right, numbers that are larger than negative 1. Okay, so or problems are very much just like two different inequalities, and we just solve them, put them together at the, on the number line. And ors normally go out, okay? Open circles because there's no equal. So let's look at the next one. Okay, all right, this example, it's less than. Less than is a sandwich or an and problem. Okay, so what we want to do is the 4.5 is going, that's how it's going to come out, whether it's positive or whether it's negative in here. 4.5 is what's going to come out of that absolute value. So it could be the negative version. Let me lower it just a little bit. All right. It could be the negative version, negative 4.5, or the positive version, positive 4.5. Okay? So the nice thing about a sandwich is that you can do all of the solving all at one time, and you just do it to 3 parts, just like we did the compound inequalities. So in this case, there's just one step. You just add 1.5 to both sides. So 1.5 plus and plus 1.5. Okay, you get negative 3, and you get carry 6. So I'll just put a 6 right there. All right, so so those are the two solutions, and it's a sandwich. So negative 3 is on the lower end of the sandwich. It's filled in because of the equals right here. Positive 6 is on the other end of the sandwich. It's filled in because it's equal to right there. And then x, or our solutions, are between those. Okay, so the number line makes a sandwich, plus we set it up as a sandwich when we solve. So just remember, less than sandwich with the negative on the left side, the positive on the right side, and then greater or with the negative that you flip the symbol, and then the positive that you keep the same, okay? And sandwiches go in and ors go out, okay? So So let's try these. All right, don't have too much room, but that's okay. All right, so this one is Greater, so let's set up and solve this one, 2 different problems. I guess I'll come off to the side and solve it, just so that we have a little bit more room. No, I might could work it in here, okay? This is Greater, so x minus 2 is less than or equal to -7, so I'm doing the negative version on the left, or x minus 2 is greater than or equal to, +7. Okay, so here's the negative version and the opposite symbol. Here's the same answer and the same symbol. Okay, so then this is easy. Add 2 to both sides. You get -5 or +9. So they're both equal to, so we fill them in at -5. Less than goes out to the left. +9 filled in. Greater than goes out to the right. Okay, so not too bad right there. And then this one, less than sandwich. So this goes in the middle of the sandwich. 4x minus 1. -9 is the lower end of the sandwich. +9 is the upper end. Okay, so then you just add 1 to both sides. You get -8 is less than or equal to 4x, which is less than or equal to 10. Then you divide everything by 4. You do get a decimal, but that's okay. And that's -2 is less than or equal to x, which is less than or equal to 2.5, I believe. Okay? So then we just graph it. They're both, and I accidentally included an equal. Take that equal out. That was definitely a typo on my part. And I caught it because when I went to graph, I wanted to double check, but it should be an open circle. So open circle at +2. Open circle at 2.5, which is in between 2 and 3. And then the sandwich, the answer, x, is in between those two. All right, so that's this. All right, so the last thing that I want to point out, I know your pages are done, but there are a couple things that you have to keep in mind for absolute value, and that is you can never equal a negative. So for example, if I were to add, let's say that's 5 and 6, so if I were to add example 7, and I were to say the absolute value of 2x plus 3 is greater than -7. Okay? Well, that actually causes a problem. Hold on. Okay. All right, that actually causes a problem because you can never take, well, this one is a little bit different. Let me make that equal to. Okay, equal to -7. Okay, you can never take the absolute value of something and get it to come out as a negative. Okay? You can, whatever's in here, it can never come out as a negative. So it cannot happen. That goes against what absolute value is. Absolute value is never negative because remember it's a distance. So because you can't ever get a negative, you can't ever get an absolute value to equal a negative, like at the very end. You can't ever take that. Then whenever you see that an absolute value equals a negative, that the original problem equals a negative, then you say DNE or does not exist. Okay? So DNE, or sometimes we use a symbol like this. That means empty set. Sometimes you'll see a symbol like this. Those are braces and they're empty, so it's an empty set. Okay? So that is something that you could see. So you always want to see, like, does it equal or is it less than a negative? Because it can never be, you can never take the bars and then get negative out when you when you apply those bars, okay? The other thing you want to be careful of, so let me add one other idea, is that before you set up your two different problems, you always have to isolate the bars. So for example, you could have something like this. Example 8. You could have something like this. The absolute value of x plus 5 minus 2 is less than or equal to 6. Okay? Well, if you notice, it's less than, so we're going to make a sandwich, but we really can't set it up yet because we don't have the bars by themselves, okay? So just like solving anything else, we actually need to add the 2 over, then we can set it up, okay? So add 2 to both sides. You'll get the absolute value of x plus 5 is less than or equal to, it's now become an 8. Well, that's actually what you want to use because now whatever's in here needs to come out as an 8. So whatever's in here can either be negative 8 or positive 8, but you can't set it up until you just have your bars. Then you can set it up. Now it's a sandwich, so now I say, okay, well that's negative 8, x plus 5 is in the middle, and positive 8 is on the other end. Then you just solve it like normal. Subtract 5 from everything, you get negative 13 and 3. Okay? So that's another thing you have to look out for when you're solving. Isolate the bars, then you apply all these rules where sandwich, gray tour, all of that other stuff, okay? So we'll practice more of those, but I want to make sure that you saw that so that you know what to do when we get to class, okay?